Okay, so let me discuss some of the, what are the relevant problem for gate examination, okay, from the network theory. I was thinking to start this session from, tomorrow onwards, but I thought that I'm gonna show you the book itself, right? So what I will do here is I will take the book, okay, the solution will be there, right? Because all reference book has got some manual solutions, right? But there might be some mistake as well. You can see here we will talk about what are the relevant questions, for gate examination, particularly where you have to focus, right? So let me directly jump to the problem here. I mean, you can see here this is the chapter 1, okay, and this book name is Sadiku, okay, Sadiku, and okay, for network theory. So this session will be beneficial for EC, for electrical engineering, and for instrumentation. So this is just going to be a sneak peek, right? I'm not going to discuss all the problems, just I'm showing you, right? So you don't have to see these solutions, right? You have to read the problem first and think about it, okay? So, because I don't have that much time to hide these solutions, right, and then show you the problem. And in fact, I don't have time to type these questions separately and make the differentiation. Okay, okay. Just I can only guide you how what kind of problem you might. Okay, you might be having lot of fear from the books, right? So just see this kind of a book and read the question. Okay, so we can cover, in fact, all the. all the book, right, for the gate examination. Okay, so you can see here this is a book, that is Sadiku book, right? So the first question is how many coulombs are represented by these amount of electrons, right? Okay, so okay, so there are number amount of electron, you can see 0.482, and okay, so you have to find how many coulombs, right? So you have to find the charge. Okay, so charge is what? Charge will be basically n times, you can say n times E. Okay, so you know that this is the coulomb. Okay, in this is the 1.602 into 10 raised to power minus 19 coulomb charge is there. So and this is the number of electron, you can say, or amount of electron they have given. So you have to just multiply it, and so you will be getting this, right? So there are four questions, A, B, C, D, and you can solve simply, right, with the help of this. Okay, as we know that your charge is what is equal to n times C. So you can solve this kind of questions, and then we move to next question. Okay, so here the question says determine the current flowing through an element if the charge flow is given. You must know how current is defined, right? The current is defined like dq by, you can say dq by dt. Okay, dq by dt, rate of change of uh, or else you can say rate of change, or you can say flow of charge or rate of change of charges, right? So dq by dt. So here q is given, you have to just differentiate, right? You have to find the slope. So charges are given and you have to find the current. Simple. This is 3t plus 8. Okay, your charge is a function of time. Okay, so you just differentiate this. So you will get 3 milliampere. Okay, you will get here as 16 plus 4, that is 20. Okay, I mean, right? So okay, so it will be 16t, right? 16t plus. Okay, so don't make mistake because there is t square. So your current will be also the function of time. You can further in, okay, you can further, right? So you, in this manner, you have to differentiate in order to find time. I hope this makes sense, right? Next question you can take is very easy questions, right? Next question you can take here is chapter 1, problem number 3. They have given charge, and you have to find the current. Okay, so you know that if current is defined like dq by dt. Okay, so what is charge then? Charge will be defined by what? Integration of the current. Okay, integration from minus infinity to t I dt. And if you start from 0 to t I dt, so you have to add some q naught, right? Okay, so you can write like this. So this is the definition here, right? Because there should be some integration constant as well, right? So minus infinity to t. Here you can see they have given I of t, okay, and they have given q of 0, right? So what you have to find here is that you have to find the so q of t integration I dt, okay, I is also the function of time plus q0. In this manner you can solve the question, right, as I told you. So just you have to integrate, so it will be 3t, and this you have to add. Okay, you can say this is going to be the integration constant. Okay, so these are the very basic question, right, just for the sake of brushing up your concept, basic concept, right, from the network theory, because in the classroom nobody discuss these things. So basics you need to cover whatever you have studied in your school days in like in basic physics, right? Then you can just integrate, and this is nothing but a mathematics, right, integration and differentiation. Okay, and now you will get the word problem here, right? So now this is a problem fourth, and they have written that the current of 3.2 ampere flows through a conductor. Calculate how much charge passes through any cross section of the conductor in 20 seconds, right? So again, this is just a basic definition, right? You have to find how much charge. Okay, so just if you know I is equal to dq by dt, right? So you can find from here the q is what, the current into time, right? Just multiply, that's it, you will get the answer quickly. Okay, so you don't have to do anything here, right? They have given they have said that 3.2 flows through a conductor, so conductor can be a wire as well. Okay, and suppose this is kind of a conductor here, and the current is flowing through this cross section in 20 seconds. So this is just a basic definition, that's it, nothing else, right? Don't consider these kind of problems are very difficult, so you can see how easy this book is. Okay, and next problem is problem number 5. Determine the total charge transferred over the time interval. Now they have given time interval, right? And you have to find the, so just why they have given time interval, so that you could put the limit of integration, right? So q is what, integration I dt, right? So integration will be from 0 to 10, right? And current is also the function of time, that is 1 by 2 t dt. So just you can this is just a math problem, right? This is just a math problem, I'm saying. And then you can see now graph is started coming into picture. So these kind of problems are very important for current gate. Okay, current trend you can say, right? In 2023, in 2024, 25, 26, 27, as as time goes ahead, more picture will come into picture in the gate examination. Okay, some graphs, some plots, some pictures, right? All the formula things will be eliminated from the gate examination, remember. Okay, so you can see here this question, right? So now what they have given here is, so you have to understand, if I say I is equal to dq by dt, what is the mathematical meaning of this? You have to understand, this is just because if you're talking about differentiation, that is slope, right? Derivative of charge, you have to find slope at some point, you can say. And if you try to find q, if current is given, so you have to find area under the current. Okay, if current curve is given, here they have given what, the charge plot, okay, with respect to time. Okay, so what you have to do here is, you have to find the charge entering, okay, is given here, right? Find the current, so you have to find the current at t equal to 1 ms, right? So you have to find current at this 1 ms. What you have to do, I equal to dq by dt at t equal to 1 ms, means you have to find the slope of this line, right? Slope of this line is 40, this is 80, and you can say this is 2, right? So 40 will be, okay, so 40 milli, I guess, yeah, 40 is the answer, right? So you have to, because this is millicoulomb and this is millisecond, so milli gone, right? So whether, okay, you are trying to find slope at a point, but slope is not going to be changing, right? Whether you find slope dq by dt at this point, anywhere, right? So simple. Okay, they are asking again the current at 6. Okay, so if they are asking at this point, here the charge is constant, so current is going to be 0. Current will be 0 at this, in this segment, right? In this interval from 2 to 8. Okay, because charge is constant. Here again the current is going to be negative, you can say, because the negative slope is there, right? You can see here negative. Okay, so these are the things we are going to learn, right? So this is just a sneak peek. We will meet in the next session from tomorrow, and we will discuss entire Sadiku, entire network theory from starting to end. Okay, only problems, not the theory. Okay, let's meet in the next session. Thank you. I hope you might have liked this session. So I'm gonna take books and I will be solving all exercises, problems, so that any kind of problem you face in the gate examination, you can do it. Thank you. And from here we will be fetching up lot of learning. Okay, new concept, new definitions, new formulas from these books, right? Let's meet in the next session. Thank you.